my name is Shubsina and again welcome to this channel. So today we will learn about some concepts of nonlinear data structure. In the previous video we have learned about the trees, and today in this video we will learn about the graphs. So in case if you don't see the previous video, please go check that and then come to this video and learn this concept. So what are graphs? A graph is another example of nonlinear data structure comprising of finite number of nodes or vertices and the edges connecting them. The graphs are utilized to address problems of the real world, in which it denotes the problem area as a network such as social network, circuit network, and the telephone networks. So we can also say that the graphs are utilized to address problems of the real world. And for instance, the nodes and vertices of a graph can represent a single user in a telephone network, while the edges represent the link between them via telephone. So the graph data structure G is considered a mathematical structure comprised of a set of vertices V and a set of edges E as shown below. So G equals to V. So from the above diagram, or from this diagram, we can say that there are 7 vertices, which are A, B, C, D, E, F and G, and there are 10 edges, which are AB, AC, this one, BC, BD, again this one, BE, then CD, this one, then DE, this one, and DF, EF and EG. So all total there are 10 vertices. 10 edges, sorry, my pardon. Then, depending on the position of the vertices and edges, we can say that the graphs can be classified into different types. First is null graph. A graph with an empty set of edges is termed as null graph. Trivial graph, a graph having only one vertex. Third is the simple graph. A graph with neither self loops nor multiple edges is known as simple graph. Fourth is multigraph. A graph is said to be multi if it consists of multiple edges but no self-loops. Next is pseudograph. A graph with self-loops and multiple edges is termed as pseudograph. Non-directed graph. A graph consisting of a non-directed edges is known as non-directed graph. Directed graph. A graph consisting of the directed edges between the vertices is known as directed graph. Connected graph. Graph with at least a single path between every pair of vertices is termed as connected graph. Then the disconnected graph. A graph where there does not exist any path between at least one pair of vertices is termed as disconnected graph. Next, the regular graph. A graph where all the vertices have the same degree. So you should remember that the vertices have the same degree is termed as regular graph. Next is the complete graph. As you can say that from the name it says itself that a graph in which all vertices have an edge between every pair of vertices is known as a complete graph. Then the cycle graph. A graph is said to be cycle when it has at least 3 vertices and edges that form a cycle. So it should have at least 3 vertices and edges. Next is cyclic graph. A graph is said to be cyclic if and only if at least one cycle exists. Then is acyclic graph. A graph having a 0 cycle is termed as an acyclic graph. Next is finite graph. A graph with an infinite number of vertices and edges is known as finite graph. Then the infinite graph. A graph with an infinite number of vertices and edges. So we can count them. There are infinite number of vertices and edges are present. So if that situation occurs, then we can say that it is known as infinite graph. Then bipartite graph. A graph where the vertices can be divided into independent sets A and B, and all the vertices of set A should only be connected to the vertices present in set B with some edges termed as bipartite graph. Then the planar graph. A graph is to be planar if we can draw it in a single plane with 2 edges intersecting each other. Then the Euler graph. A graph is said to be Euler if and only if all the vertices are even degrees. Then the Hamiltonian graph. A connected graph consisting of a Hamiltonian circuit is known as Hamiltonian graph. So these are all the classification of graphs based on their depending on the position of the vertices and edges. So it is not necessary to remind them all, but to explain it better, I am giving this as an example and you can see it later also. these things are not all necessary that you should guys remember, and this is not important at all. Just you can remember at least 5 or 6 or 7 names of this graph, and that will be all. So next we will learn about some application of graphs, which is the graphs helps us represent routes and networks in transportation, travel and communication applications. Then the graphs are also used to display routes in GPS. Graphs are also help us represent the interconnections in social networks and other network-based applications. And graphs are utilized in mapping applications. Next is graphs are responsible for the representation of user preference in e-commerce applications. And graphs are also used in utility networks in order to identify the problems posed a local or municipal corporation. Then the graphs also helps to manage the utilization and availability of resources in organization. And we can also say that it is used to make document link maps of the websites in order to display the connectivity between the pages through hyperlinks, and it is also used in robotic motions and neural networks. So these are the basic applications of graph. In the next video we will learn about the basic operations of data structure and its types. So till then, bye bye.